So this is an example of a more tricky percentage problem, in that we've got £6,000 invested for 5 years, compound interest that we don't know, quoted at X%, and here's the closing value at £8,029.35. So let's just have a look what's gone on. So we've got £6,000, and that turns into 802,935. And it does it in 5 years by X%. So this is X% for 5 years. So just as a reminder of the mathematics involved in this progression, let's just imagine a different bank account, and I still invest £6,000 in it, has a 10%, chance would be a fine thing, amount of compound interest each year. This would produce a multiplying factor of 1.10. So my £6,000 will be multiplied by 1.10 to the power 5, because I've left the £6,000 in for 5 years, just the same as the question. And this must be equal to, well, an answer. And that answer is equivalent to the £8,029 up here. So in our real question, there must be an equivalent multiplying factor. So let's call that y. And then we can easily convert y back to x for the answer. So I can say that £6,000 multiplied by y raised to the power 5 must be equal to 8029.35. Well, that's an equation we can solve. Y to the 5th is equal to 8029.35 divided by £6,000. And if you put that into a calculator, we get y is equal to 1.0599999908. Now, the reason we've got this rather odd answer, which is so near to 1.06 that it can't really be distinguished, is because 35 pence was rounded up to a whole number of pence. There could have been more numbers after this from the calculation, but they've given the customer 35 pence because we don't have any divisions of money below a penny. In reality, y must be equal to 1.06. Well, hopefully you can see that if y is equal to 1.06, the percentage, X%, must be equal to 6%. Because just as 1.10 came from 10%, 1.06 must come from 6%. So that is your answer.